Hello everyone, this is Jabal Sonisha B. My register number is URK23CS1119. Today we are going to see about my sixth experiment, that is performance analysis on regression techniques. My first question is, develop the linear regression model for the given data by step-by-step manual procedure. So here they have given a constraint that don't use scikit-learn library. So they have given the data. We have to calculate the intercept and regression coefficient in y is equal to b naught plus x b1 and analyze the various performance matrices: mean squared error, mean absolute error, root mean squared error, and r squared. Let's go on to the answer. So first we are importing NumPy library. Then we are importing the data. So that which is in the tabular column. So spent is X and the sales is Y. Then we are calculating the mean. Then to calculate the regression coefficient, we have the formula that B is equal to summation X minus X bar into Y minus Y bar divided by summation of X minus X bar the whole square. So the numerator is the NP dot sum of X minus X bar mean into Y minus Y bar mean. And the denominator is sum of X minus X mean power 2. So B1 is equal to numerator divided by denominator. So B naught value is equal to mean value of y minus B1 into x mean. So this is our regression coefficient, regression equation also. We are printing it. Then for the prediction, we are giving the formula as y predict is equal to B naught plus B1 star x. For next step is performance matrices to find mean squared error, mean absolute error, root mean squared error, and r squared. So to find mean squared error, we are just giving the mean of y minus y predict in power 2. For the absolute error, mean of absolute value of y minus y predict. Root mean squared error is square root of mean squared error. Then we are gonna find r squared. For that we are giving the total, like giving a variable, and we are storing it the value of sum of y minus y mean of y power 2, then sum of y minus y predict power 2, then for the r square we are giving that 1 minus r divided by the total value which we have stored. So then we are printing the value. Our output is going to be, first we have found the regression equation that y is equal to uh, b naught plus b1 x. So this is our regression equation. And for performance matrices, this is our mean squared error, this is our mean absolute error, this is our root mean squared error, and this is our r square. Our second question is, we have to develop the linear regression model for the prediction of median value of owner occupied homes in Boston in terms of weight distance to 5 Boston employment centers, property tax rate, nitric oxide concentration using the scikit-learn. Divide the data into training 75% and testing 25%. Then display the intercept and regression coefficient for the following cases. We have to analyze the impact of this to the median value of owner occupied homes, then tax, then NOx. Then we have to predict the Y value for testing X and analyze the performance matrix with the actual value Y and predicted value Y bar For the above three cases, identify the input parameter that has greater impact in the prediction of median value of owner occupied homes in Boston. Then we are going to plot the regression line for the input parameter that has greater impact in the prediction of median value of owner occupied homes in Boston. Let's go on to our answer. So first we are loading the data set. Then we are selecting the features for this tax and NOx. Then we are giving the values for that median house. Then we have, for the first question is to train and test the 75% and 25%. For that we are splitting x and y, giving the size. Then the length of x is going to be at n. Then we are giving n's for splitting the n square n into 1 minus text size. Then we are returning the value. Then for this train, this stress, we want this train, this test, and this white train and white test. We are splitting the values. For tax also we are splitting the values. For NOx also we are splitting the value. For simple linear regression, we have created three functions. One is fit linear. The another thing is we are going to predict, so we are giving the predict function. And the third value is r square value. And the third one, the B question is to fit the models. We are going to fit linear. So that we have trained right. We are fitting the linear value for this tax and NOx. Then we are going to predict and we are going to square the R. So for predict, we are using predict keyword and we are giving the test for tax, disk and NOx. And we are printing the R square values. Then we are going to find the best features. So R square scores is equal to, we are just finding the best features. So for the best, we are going to find the max value among these. So then the best feature is going to be that. The E question is, we are going to plot the regression line. So if the best is equal to this, we are going to plot uh x plot, y plot, then the train, the disk and the y disk. Else, if best is tax, means we are going to give the tax test, white test and beta text. Else we are going to go with NOx. Then we are using scatter plot for this. Then line plot, giving the x label as best dot upper arrow and y label is MEDV, and the title is going to be linear regression, and we are going to plot it, and we are getting the output. For the test, the intercept value is this, the coefficient value is going to be this. For the tax one, the intersect is going to be 29.07. The coefficient value is minus 0.12. The NOx value is intercept for NOx, the intercept value is 33.95. For the coefficient value, for the coefficient of NOx is going to be the minus 17.03. The R square value for this is minus 3.44 and the R square value for tax is minus 1.35. The R square value for NOx is minus 1.95. The best feature is tax. The maximum value among these three is minus 1.35. So the best feature is tax. We are plotting the graph for the actual and regression line. That's all for my sixth experiment.